Okay, so number 25 says let f be a function that is differentiable. So therefore we know it should be continuous by default. Remember how it works. It only works one way. If it's differentiable, it's continuous. However, if it's continuous, it doesn't mean it's automatically differentiable, like we discussed long ago with an absolute value function of how this cusp was non-differentiable, but the function was still continuous. Alright, so we're looking at the open interval from 1 to 10. So if I looked at this like a graph, we're looking at 1 all the way to 10. It is differentiable. Therefore, it's continuous, and we can take slopes everywhere on this interval. Okay, so I'm going to go ahead and look at the other pieces. F of 2 is negative 5. Remember, these are just x and y values of the position function. So f of 5, which is approximately here, the answer is 5 for my output. So I'm going to go up to a y value of 5. And then finally, f of 9 is negative 5. So at 9 about here, I go back to negative 5. Remember, this is continuous. So I do not just draw cusps like this, because it's also differentiable. It's going to be smooth throughout. So it'll be smooth here, smooth, and then smooth. Now, it is going to be closed, or it can be, because this says it's continuous on 1 to 10, domain-wise. And it's differentiable means we can take the derivatives of everything, not including the endpoints. Remember, you cannot differentiate an endpoint. So everything's still good. So let's look at our choices. F has at least 2 zeros. Well, you see this. It does have at least 2 zeros. And the reason why it says at least is because we could have drawn it something like this, gone through, then went through that point, then came down, and had a bunch more zeros. Okay? And everything still works out as far as the values that were given to us. Okay? The graph has at least one horizontal tangent. By the looks of it, it has at least one, because we see at least 3. And then for some C, in between 2 and 5, so if I'm looking at this, in between, so 2 was about here, 5 was here, there's an input that exists to where its y value will be 3. Intermediate value theorem says, of course, there has to be a C, because it's somewhere around here that would yield this continuous value, or this continuous function, a possible y value of 3. So the answer on this one is going to be all 3 of them, E.